Right, compound interest and appreciation, depreciation. So if we look at question 1 here, Caris, it says invest £7,600 at 4% per annum compound interest. What is the value of her investment after 2 years, 5 years and 18 years? Okay, so the way we've traditionally done this is you look at the interest that's paid here. So Caris has put 7,600 into, say, like a bank account, and then you're going to pay 4% interest every year. Okay, that's what per annum means, per year. But because it's compound interest, of course, when you work out 4% of 7,600, okay, you will then add that interest on to 7,600, and it'll give you a higher amount, won't it? Once you added that interest on. So when at the end of the first year, she'll end up having more money in there, 7,600. She'll have a bit more. She'll have the interest paid. In the second year, then, of course, when she gets 4% again, it'll be of the higher amount. It won't be just of that. It will include also the interest she earned in the first year. So in the second year, this 4% will be even more. Okay, so she'll earn more interest in the second year, and again, that will follow in the third, fourth, fifth. She'll be earning more interest every year. Okay, now traditionally, of course, we work out 4%, all right? Work out 4% of 7,600, and we get 0.04. Okay, that's what 4% is, isn't it? Times 7,600. Okay, and times 7,600, and you get £304. Okay, now that's the interest, of course, in the first year, right? So then, at the end of the first year, she'll have 7,600 plus then this interest of 304, which will equal 7,904. Now, of course, you could do that, couldn't you? And you could do it for 2 years easily. You could go again, right? And you could work out 2 years straightforward. 5 years you could do, but you know, it would take a bit of time, right? But you get that. 18 years, of course, is going to take a lot of time in the exam to actually cover that ground, all right? So we've got to look at a quicker way of doing this. The way I want you to think of it is this, right? If you think about what she started with this, didn't she? She started with this. If you think of that as representing the original amount that she's got, so that's your 100%, right? That's what she starts with. That's her investment. 100% of her investment is 7,600. She then gets given, doesn't she, 4% interest. So really, we're adding 4% on to this total, aren't we? Okay, that's what we're doing here, isn't it? We've got 100%. Here's what she started with, and we're adding on 4%. Now, percentage-wise, if you look at that, that is 104%, isn't it? 104%. And we can change this to a decimal. This can be 1.04, of course. You know, just divide it by 100, and you get your decimal. Now, what we've got here is what is known, right? What is called as a multiplier. Okay? It's called a multiplier, because basically we can use this to get our answer by multiplying. So instead of doing all of this stuff here, you know, where you're working out 4% and then adding it on, okay, you could go straight by working out 104%. Does that make sense? Because that's what we're doing, isn't it? That's what we're doing here. We've got the 100%, what we start with, and then we're adding on 4%, which we've just worked out, okay? And it's given us that answer there, which effectively is 104%, okay? And we end up with more, don't we? And that's why it's more than 100, because we end up with more than what we started with, all right? But instead of doing it this way, working out 4% and adding it on, we could just use this multiplier here. Use this percentage. Rather than 0.04, use 1.04. So if you do that, okay, watch what happens in your calculator. 7,600. Okay, you get 7,904. So it comes out straight away. Okay. Of course, that is the first year, isn't it? That is the first year. Of course, to get the second year, if we think about it, what you would do then is, okay, you take the 7,904. Traditionally, you would work out 4% of this and then add it on. But instead of all that, why didn't you just times it by 1.04? So 7,904 times 1.04. Okay, and it comes out. Okay, it comes out straight away. 8,220. and 16 pence. So that's your second year. You've actually answered now part 1, haven't you? Okay. Now to get 5 years, of course, we need to keep going. We need to keep timesing by 1.04. Okay. We'd have to do it another 3 times, wouldn't you? To get 18 years, we'd have to keep going quite a lot. There's still a bit of work there. But what I want you to think of is we started with 7,600, we times by 1.04, and then we times again by 1.04, and it gave us the second year. To get the third year, you'd have to times again by 1.04, and so on. So wouldn't it have been easier for the second year, to get the second year, wouldn't it have been easier just to start off with like this? Wouldn't it be easier to just do 7,600, which is what we started to begin with, times it by 1.04 the first year, and then times it by 1.04 again second year. That's what we've actually done here, isn't it? Times it by that, and then times it by it again. And of course, a better way of writing this, 7,600 times 1.04 to the power 2. Okay, because you're timesing that by itself, so it's squared. So my calculator, 7,600 times 1.04 squared, and it comes out, doesn't it? £8,220 and 16. Okay, straight away. Now you might be thinking, well, for 5 years, can't we do the same? So this time it would be 7,600 times 1.04 times 1.04 times 1.04 5 times. Well, why not just go straight, put it to the power 5? Okay, so 7,600 times 1.04 to the power 5. And you get your answer. So £9,246.56 to the nearest penny. And then for 18 years, 7,600 times 1.04 to the power 18. Okay. So I can just press back there, can't I? Just change that to 18. Okay, and I get £15,396.21. Okay. It's actually more than doubled, isn't it, after 18 years? Fantastic. So it's a much quicker way of doing it. Now let's have a look at number 2 then. An antique is bought for £2,000. Its value appreciates by 8% in each of the following 7 years. In the 2 years that follow, its value depreciates by 15%. Determine the value of the antique after the 9 years and determine how much has it increased or decreased in value. In this case here, appreciate, right? If you see the word appreciate, it just means to increase. Okay, that's what it means. So it increases in value by 8% in each of the following 7 years. So if we think of our £2,000 as our 100%, okay, of course we want to, because it's increasing, because it's appreciating, it's increasing, we want to add on 8%. So that will give us 108%. Okay, so our multiplier will be 1.08. Okay, that's our multiplier. Now, of course, it does this for 7 years. So all I've got to do is 2,000 times 1.08 to the power 7. Okay, so get my calculator. 2,000 times 1.08 to the power 7. Okay, and I get, there you go, that's it there, £3,427 and 65 pence rounded there. Okay. So you get your answer quite quickly in your calculator. It's important that you write this down and all of this work in here. So you've shown how you got your multiplier. Okay. So that's what happens in those 7 years, is increasing by 8% each year. So this is a much quicker way of doing it. It says then in bullet point 2, in the 2 years that follow, its value depreciates by 15%. Now depreciate means that it goes down. So we're starting with this figure, aren't we? £3,427.65, £3,427.65. That now represents our 100%. Okay, that's what we're starting with after 7 years. Of course, it depreciates. Now depreciate, okay, depreciate just means to decrease. Okay, so it goes down. So we're taking 15% off. Okay, so in fact now we get 85%. 85% of the value. It was a decimal, That's 0.85, isn't it? Okay. And this goes on for 2 years. So what you need to do now is 3,427.65. You're timesing it by 0.85, because it's 2 years, power 2. So 3,427.65 times 0.85 squared, and it comes to £2,476.48 if I round that to 2 decimal places. So you can see then after 9 years this is what it's worth, and you can see how much it's actually gone up, isn't it? You can see it's asking for how much it's increased or decreased by. Well, it's increased, isn't it? Increased by £476.48. Okay, finally then, question 3. This is important, this one, okay, for the homework as well. Jack takes out a loan of £400 at 2% per day compound interest. If Jack pays back what he owes in exactly 3 weeks' time, how much will he have to pay, and how much has this loan cost Jack? Give your answer to the nearest pennies. Okay, so here, basically he's had a loan, right? £400 loan, so he's got to pay interest, isn't he, on this loan? So he'll pay back a lot more than £400, okay? He'll have to pay more than £400. But it's 2%, isn't it? The interest is, but it's per day. Notice that. So basically you're working out 2% every day, and it's building up that way. Okay, so you could work out 2% of 400. That's your interest for the first day, but you'd have to add that on. Okay, so I think 2% is £8. So you add that on, now you've got £408. So you have to do the same then for the second day, and so on. But of course we don't want to do it like that. We just need to get our multiplier, don't we? So remember now, 400 represents our 100%, and we got to, because we're paying it more, we've got to pay interest, you can add on that 2%, so you get 102%, which gives my multiplier of 1.02. So 400 times 1.02, of course, it's 3 weeks, but it's per day this compound interest is. So 3 weeks, of course, means 21 days, doesn't it? 3 lots of 7. So this will be 2% for each of those days, so the power is 21. So 400 times 1.02, the power 21, and that comes to £606.27 pence. So that's how much you'd have to pay back. Okay, so we've answered part 1. Part 2 then says, how much does this loan cost Jack? Well, he had £400 given to him. He's got to pay back £606.27. So actually, it's cost him £206.27. So it's actually cost him to have that loan. He's got to pay back an extra £206.27 on top of the £400 that he's already borrowed.